Let's get started with part 2 of Lab 2 on plate tectonics. And for this part, we're going to be looking at a map of the Juan de Fuca plate, which is just offshore Oregon and Washington. So here is the map that shows where the Juan de Fuca plate is. And we can see, once again, we've been given the age of the ocean floor. It varies from 0 right along this divergent plate boundary here. And it gets up to about 14 to 16 million years in this direction, and down in this direction, not so much. So one of the first questions you're going to answer is, within 100 miles of the Oregon coast, how old is the oldest part of the Pacific Ocean? 160 kilometers, about 100 miles. You can, once again, just use the bottom one, this movable scale bar here to go out. Each one of those divisions from black to white or white to black is 100 kilometers, so 160 would be something like that, and just kind of drag that along until you get to the oldest part of the ocean floor that you can see. This is younger here, so probably somewhere in this area here. And then you'll just put in your answer there. And then it asks you why there is no, explain why there is older ocean floor on the map, but not close to the Oregon coast. So looking at this map here, we can see that once again, it gets up to 14 plus million years old in this direction here from this divergent plate boundary, but it's missing here. And as you may imagine, it has to do with this red line here. This is actually the Cascadia subduction zone. And I think if you can review the material and understand what goes on at a subduction zone with oceanic lithosphere, you should be able to answer that question there. And so it asks, this is a subducting oceanic lithospheric scenario that's going underneath the North American plate, and it's under parts of Oregon, under the parts of Oregon that include Central Oregon. So it's asking underneath Mount Jefferson, how old would we expect the oceanic material to be, older or younger than 14 million years? For that, I would suggest just drawing a line on the map from Mount Jefferson, because something's under there, out to where the middle of the divergent plate boundary is, and then just comparing it with the other side and seeing what sort of age you would expect the ocean floor to be under Mount Jefferson. This is another velocity question, just like you did in part 1 of the lab. If the seafloor at sea was created 9 million years ago, what is the velocity of the Juan de Fuca plate? And so for velocity, you need distance and time. I'm giving you the time, right? This it's taken 9 million years for the oceanic material to move from here to here. And then you'll just measure this distance, once again, using the scale bar over here, with each of these divisions representing 100 kilometers. You'll have to convert those kilometers to centimeters by adding 5 zeros to your measurement. And then you'll have both a distance and you'll have the distance in meters, and you'll have the age, the distance in centimeters, and you'll have the age in years, and then you'll get a number for number of centimeters it moves every year. So there was a huge earthquake on the Cascadia fault zone. The last one recorded was in 1700. It was a devastating earthquake, and we're overdue for another one. So it's asking, during that time from 1700 until the current day, until this year, how many centimeters of ocean floor has subducted underneath the North American plate? So you're going to get an answer in centimeters here. Let's say that's 2 centimeters. And then you'll just multiply by the number of years it's been since 1700 to get the total number of centimeters that of ocean floor that have been pushed underneath North America since that time.